Hello, hello, Shagathon here. Welcome back to another Rust coding stream here on the 19th of October 2022, local time 1738. We're going to be continuing the roguelike tutorial in Rust, where last time we did ranged scrolls and targeting. So I'm going to see if I can get through a couple enemies here and show one of those. There's one. That's not good though. It's not good at all. Okay, that should be okay. Hopefully it doesn't hurt me. Actually, what if I target like next to it? Yeah, there we go. Okay. So there was an example of what we implemented last time. That's the fireball scroll. We also have magic missile, which is a single target. And we have a confusion scroll, which basically just freezes the enemy in its tracks. And I'm not sure which one I'm looking at there. Oh, I killed myself. Oops. Well, I think that's magic missile. I think confusion was, yeah, it's magic missile. Alrighty. Well, that's a quick little demo of what we had last time. So let's go ahead and jump into today, where we're going to be doing loading and saving the game. I don't like loading and I like saving and loading. I don't know why. I like saying it the other way around. But we're going to be going over this. I don't think we're going to be doing delving deeper. This is a fairly lengthy session. Delving deeper is substantially shorter, it looks like, but I think we'll probably just go with this. We'll see how things look by the time I'm done here. So let's get started after I get a quick drink of water. In the last few chapters, we focused on getting a playable, if not massively fun game going. You can run around, slay monsters, make use of various items. And that's a great start. Most games let you stop playing and come back later to continue. Fortunately, Rust and associated libraries makes it relatively easy. A main menu. If you're going to resume a game, you need somewhere from which to do so. A main menu also... Oh, I want to try something real quick. Sorry to just break the flow, but does it lag? It still lags a little bit. So I've been like pointing out that as I mouse over things here, it would lag. It's better. I just restarted the computer. Which is part of what made me late, because it was fighting with me restarting, and then I had to get everything started back up. Alrighty, if you're going to resume a game, you need somewhere from which to do so. A main menu also gives you the option to abandon your last save, possibly view credits, and generally tell the world that your game is here and written by you. It's an important thing to have, so we'll put one together. Being in the menu is a state, so we'll add it to the ever-expanding run state enum. We want to include menu state inside it, so the definition winds up looking like this. So it's another named, like, I don't know what you call this. Because, again, the ones I've seen, it's like a tuple, and they're unnamed data associated with it. I did not know you could do it with named data as part of the enum. So it's like a struct. It's like a struct variant of an enum versus a tuple variant of an enum. I'm not sure. So then we'll add a couple of enum types in GUI.rs to handle main menu selections. Alrighty. And we're going to do some stuff. Alright, so we're going to start getting some errors. So let's go ahead and implement those first two things real quick. And we'll let it get mad at me. What am I hearing? Hold on. I swear, I'm talking and I keep hearing some weird sound. It almost sounds like, you know, the sound when you hear your phone vibrate, but I don't feel it like vibrating the desk or anything. I don't see notifications coming up. I'm like, what is this that I'm hearing? And it's like a lot, like boom, 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 like over and over, like a bunch of stuff just happened. So we're gonna make this menu selection, and it's gonna be GUI main menu selection. So interestingly enough, we're going to pull this from the GUI. Also interesting. Okay, I was about to say, also interestingly enough, it didn't get mad. But now it's mad. I'm going to say later on that update, which is weird. I just restarted VS Code, given that I restarted the computer, and apparently that did not update it. So now we're going to go to GUI.rust. We're going to make a couple of things in here. Derive, partial, equality, copy, clone. So one thing you'll actually see is if you if you just derive partial EQ and don't derive EQ, you can actually get that showing up with like Clippy and stuff saying, hey, are you sure you don't want to do both? Like, you could do both. In some cases, you can't always do equality, but in some cases, when you can, it'll actually suggest it. So result, so we have a main menu selection and a main menu result. It's going to be no selection, selected, main menu selection, and it's going to be selected with the main menu selection. So guess what I'm going to do? I'm going to copy that and bring it down here and just change this. We're going to have no selection and selected. So I'm curious what the no select, how it's going to be used. If we don't have a selection, then why do we put something in it? We'll see how that works. So yeah, your GUI is probably now telling you that main has errors. It's right. We need to handle the new run state option. We'll need to change things around a bit to ensure that we aren't also rendering the GUI in the map when in the menu. So we rearrange tick. Oh, my favorite thing. Okay. So in tick, the first thing we're going to do before clearing the screen or anything, let mute new run state. And then in the scope here, let run state equals self.ecs.fetch run state. Now I'm going to go on a little branch here and say we could do this thing again. This would be fine, and I see no reason it would make the borrow checker angry. Because when we're dereferencing it, we get rid of that borrow. This is what I did before, so I don't see the need to make a little scope there and stuff. And I don't, just aside, you know, just a little aside or a little note on how I'm going to do things slightly differently than what they have, but it's all good. So let's see, then we do the context clear screen. But then we don't want to draw the map. We want to do that elsewhere. So it's going to be, the next thing is going to be match new run state. Match, actually, can I just scoot this other thing? Yeah, I could just scoot all of this. So here's what we're going to do. Watch this. There's a nice little thing we can do. This is, oh, I still have that semicolon there, but it's valid either way. But I used to be assigning something from the match and I left that semicolon there. So we're going to highlight all that, and if I hold Alt and press up, look at that, it's even putting it into the indentation properly, like into the different scopes. So before doing any clear screen or anything, we're going to put it there. And then first thing we want to do in match new run state is run state main menu, and it has a dot dot, but that's not any syntax I'm aware of. Oh, we're actually, oh, I see. Okay, hold on. Actually, no, it is. It says ignore. Because it's like a struct. It is. Again, I'm so used to doing, well, there's a couple things. I'm so used to doing like this, but I guess that doesn't work because it's like a struct. Interesting. So it is a syntax I'm aware of. It's just, I'm not used to seeing it with an enum. I'm used to seeing it with, if you're like taking a struct and matching against it. So this is the first thing we're going to do is nothing if we hit the main menu. Otherwise, I mean, obviously we're going to put the code in there later. So then otherwise, for everything else, it's going to be draw map, self.ecs, and context. And then let positions and all that stuff, which I think was down here. Yeah. So all this goes in there. We can get rid of this clear screen. This is a bit of a messy refactor. Are we doing... Yeah, I think I see what we're doing. Okay. We'll go ahead and put this in here. So positions, renderables, map, mute data, sort by, for, and GUI draw. Okay. Now it's going to say unreachable pattern here because I moved these into this match, and it's not exactly where we want them since I see how things are being done. So I'm going to cut all of that. This is now once again a valid match statement. And then down here, I assume we just want to make use of the new run state that we already have. So we're going to say match new run state. Hold on. I got to look at the matching braces here. So that's a scope, that's the run state, and that's the match. Yeah. Well, yeah, they're using the underscore. So we do need to have another match. And then we're going to do a main menu match in here. I'll just put it at the bottom. Now, that shouldn't really be an issue here. Order doesn't matter on a match because you're not going to do multiple matches per match. So you're not going to have logic from one match going into another in the same tick. Let result, GUI, main menu. I'm a little confused at some of this, so we're going to have to break this down. I'm a little confused why we're doing a match at the top. We're doing a different match down here on the same thing. So I hope I'm not missing something, but it's not extremely clear. UI main menu result. No selection. Selected, okay. And we're going to do new run state equal run state main menu. And now it's going to be selected. Okay, and then the next one here is going to be GUI main menu result selected. So if there's no selection, we just make another thing that's... I'm gonna have to break this down once we go through. This is a little odd. I'm getting ahead of myself. Oops, it's main menu result selected. And then what are we gonna do with it? Match selected. GUI main menu selection. New game. New run state equal run state pre-run. And this is going to be the same for load game. I want to do this, but I understand why we're not doing it. So what you can do is you could do an OR here and match against both of those conditions. So we're saying it's either, do you need double? No, it is a single. Okay, I thought so. I was like, it was fine, but I didn't know if it was going to do some kind of bitwise stuff. No, it's good. I don't know why I second guessed myself. But you could do this here to match against either one since they're both doing the same thing. We don't want to do that because a new game and loading the game is not the same thing. And we don't have the logic in place yet for them to do different things, but we know that's going to happen at some point. So I'm not going to try to be clever and get ahead of it because I can see what's going to happen. So we could just exit the process hard right here. And also, I've seen this before, but I don't know why there's the prepended double colon, because that's odd. For some reason, this main menu... Oh, we haven't made it yet, duh. Okay. So let's go back to the browser and try to break down what's happening, because I'm going to reread this whole thing, and we're going to go through it here, because I am actually confused about something. So your GUI is probably telling you main has errors. We need to handle the new run state option. So we'll change things around a bit to ensure we aren't also rendering the GUI in the map when we're in the menu. So we rearrange tick. So tick is this. We get the new run state, which I've already done. We do context clear screen, and then we do a match. Now, if we follow the brackets here, that's open, close. That's open. This one here matches this one, so that's that inner scope, meaning this is for the run state, and this is for the match. And then there's dot, dot, dot. It's not really clear, but what we see and what we know based on how matches work is this underscore is everything that's not main menu. So we're saying if it's a main menu, oh, no, I see. Okay. If it's the main menu, don't do this. But if it isn't the main menu, draw the map and all that stuff. Okay. That's literally all it's saying. So that's the code that draws the map, right? And then we then match on it again down here to do the logic to transition between the different states, when we're in the menu to do other things. Okay. So yeah, this is just back in our other big match statement that we've been working with. Okay. So that actually makes sense now that I'm speaking it aloud. But this is just moving all the draw map and GUI code from where it used to be. So we're still going to have a UI, but it's going to be a different UI. So I would almost want to, if I were writing this, I would want to extract the UI somehow into something a little more generic, I guess, where instead of saying draw UI and it's a specific type of UI, I would want the UI to be any kind of menu or whatever. So somehow extract the view away and just say, hey, draw me this UI and then pass it whichever one you need. So then you could say, draw the menu UI, or draw this UI, or draw that UI. I would want to try to do something more like that, but it's a little complex, but I think it would be nice. So anyway, for the run state main menu match in the big match statement, the one we care about for the logic, we get a result from the main menu. If it's no selection, we see no selection selected. But basically we're setting main menu back to the same thing we're already on. Right? So what I mean is setting new run state. New run state just becomes another main menu. Except we ignore this inner thing here. Whatever selected is, we don't care about. But whatever we get from no selection selected, again, that doesn't make sense to me. If there's no selection, why is something selected? Are we literally talking about what thing in the menu is highlighted? Like if you're scrolling up and down between choices, maybe that's what is meant. But until I see how it's implemented, I can't say. But that may be what's intended here, is like your cursor is selecting this thing, but you haven't actually made the selection. Maybe that's what no selection means. But then in the case of a selected, we have three options: new game, load game, and quit. Now again, in this case, new game and load game both do pre-run, so we could and have them both do the same thing, but we're probably going to do some different logic for load game, so it makes sense to split these apart. So they say we're basically updating the state with the new menu selection, and if something has been selected, we change the game state. For quit, we simply terminate the process. For now, we'll make loading and starting a game do the same thing. Go into the pre-run state to set up the game. So last thing to do is to write the menu itself. So in menu.rs, yeah, we do have menu, don't we? No, we don't. Wait, in menu? Hold on. In menu or GUI.rs? Because their code, I'm gonna check their completed code because there's a discrepancy. If we look here, their code has whoops. Their code has GUI main menu, which would mean put it in GUI.rs. Unless we put it in menu.rs and then export that into GUI.rs and then export it out. But that would be incredibly complex. I mean, that would be like a lot of steps. So let me see if they actually made a menu.rs. No, I don't see a menu.rs file. Main menu. Yeah, it's in GUI.rs. Okay. So little typo there in the tutorial, but that's that's why we pay attention. We try to catch these things. So let's go down to the bottom here and make a main menu. So it's a public function, and it's called main menu, and it takes the game state, which is nmute state, takes the context, which is nmute rltk, not thtk. And now we're going to do main menu result, which makes sense. The function returns a result. So they've built a case here where we're not using the actual Rust built-in result type, which is fine. You don't have to. This is just as powerful as that result type because you are forced to handle each variant that comes out of this. And it's very common that you might build your own results. We've already seen item menu result. It's very common you might build your own or build your own little error types for convenience. If you have specific error types or specific results that make sense for your program in a specific context, those enums can be really nice and expressive. So we're going to let run state equal gs.ecs.fetch. This is maybe the first time, one of the first times that we've actually got the run state outside of that one place in main. So we're actually not getting it as mutable though, which makes sense. Print color centered. We're gonna let that one match statement in there do all the work on keeping it, on mutating it. So this is just doing the work of checking against it. And what is the text? Rust roguelike tutorial. Alrighty. And that's it. That's our menu. No, I'm joking. It's not our menu. If only it were that easy. It's a big beefy function. Try to get it all on my screen here. Okay. If let run state. You gotta love the if let. It's funny if you watch all my coding streams. Initially, I was like, I don't know quite how if let works. Like it always confuses me a bit. And all of a sudden now I'm just like, I got this. I love if let. So run state, we are this is some interesting stuff going here because we are destructuring this struct, if you will, this enum struct variant. So we're saying dereference the run state, and then this is not a way that I've actually seen if let used before, which is really interesting. So I wonder if I could have done that with other examples, like, let's see, struct test x I32 y I32. and then say let test, we'll let t equal test x 12, y 12. So I make this t here, and then can I say, let me do this so it's not mad at me, by the way. Can I then say if let, and then hold on, I'm thinking about how I would actually structure this. I mean, would it be test and then x I y j equal t, and then print line I and j? Yep, you sure can. Let me return a main menu result. Okay. Yep, you sure can do. No, irrefutable. Right. So, okay, yeah, this is what I was thinking though. Oh, whoops, not there. No brackets. Yeah, you could totally. Whoa. Okay. So if let just got even more interesting, because I could just slap a struct against it. In fact, you wouldn't do well. You might do that. You might do that. What if I also had z I32 and z is also 12, but then I just said dot dot. Yep. So what I could do is I could fix some things here, or I could then say z. I could probably, can I just get rid of the I? Can I do this? Yeah. That's interesting. So you could the way I view if let with this in mind is that it's a bit like pattern matching against a single pattern. So what I mean is, well, no, it is, because the match statement, so what you would normally do is you have a match on an enum, match, this is going to be irrefutable, like it's a dumb one, but match sum 12, and then I need 2 match arms, but we know the none arm can never happen, right? We know it can never happen in this case, so I know it's a terrible statement. Like, I know it's a very terrible piece of code, but the point is, in this case, what if we wanted to say something like this? Print line, the number is X, and then we print it. So what if instead of, you know, hard coding sum 12 here, we got back an option from some function, and then we don't care about the none. We want to ignore it, right? That's where if let comes in, right? So what you do in that case, you say if let sum x equal sum 12. Again, you would have a variable. You wouldn't do it that way. You do print line, the number is blank x. And then that's a way to say, well, because we're not using the none here, let's throw that away. We don't need that branch of the match arm, right? So let's just throw it away, and let's only focus on the sum variant here. So that's what we're basically doing here. It's the same thing, except it's a little bit more concise. I mean, in this case, it's barely more concise, but it's a little bit more concise. It could be a lot more concise depending on what you're doing. But the point is, this is like the same thing here, because if you only want to do this for like one specific pattern, instead of doing a match statement on T, and then it would be like test X, Y, 13, Z. And then it's going to say all patterns are not covered. It's non-exhaustive. And if we actually look at it, we have to go from I32 min all the way up to 12 for Y. We have to go all the way up to 12. And then we have to do, because we've hard-coded 13, right? And then we have to go all the way from 14 to I32 max. So it's really saying you have to cover every possible value for Y. So then we could do something else. We could do another one, X, and then we'll say Y. Can I do underscore Z? I don't know if that'll work for this. Yeah, you can. So that just every other Y match on that, you know, or I could say something like this. And that covers every other pattern too, because it says ignore the other fields, right? But in this case, like, again, what if I want to do something here, but do nothing in every other case? Why are you mad? Oh, because I'm bad at comments. We'll do the lazy way. Do something. Oops. And then do nothing. So in this case, if we're going to do nothing here, why do we need to specify this match arm? So yeah, it is interesting. We can do an if let on a struct like that. I never knew that was possible. That was a huge tangent, but it was a learning experience because I didn't know I could even do that. And I just became more fascinated by if let than I already was. And I was glad to see them doing something that I didn't know with it, because sometimes I'm probably overly critical, like they could do an if let there, but this was a case where they did one that I didn't expect, and it was pretty cool use of it. So what we're doing here, we're taking the run state, and if the run state matches this pattern, so it's main menu, and then we are naming menu selection, which is the piece of the main menu variant. We are naming it selection. So in here, we have a variable called selection now. Okay. We're going to say if selection equals main menu selection, new game. Oh, there's so many of these CTX prints. I hate them. 24 RGB. Wait. Oh, print color centered. RGB named RLTK black. And I'm going to say some text, because I want to copy this and reuse it, and I'll fix all the text in a minute, because there's a bunch of these and I hate typing them out. All right, we'll fix this. It's white and black, and that's all for that branch. If selection equal main menu selection load game. Now I wonder why oh, I see what we're doing. Yeah, I see what we're doing. Okay, it makes sense. Else, boom. So these are both 25, so we're moving one line down. And I think this is going to also be white and black. magenta and black, and white and black. And this is going to be the same thing. It's probably going to go to 26. Haven't even looked yet. Yep, it does. And it's quit. And the text for these is begin new game. Yoink. This is going to be load game. This is going to be load game. Because what I was wondering a minute ago was, why are we not doing a match on this? Why are we doing if? Well, I was like, okay, but then what is the else? So what's happening here? Without even seeing it in action yet, my brain has already pieced together what's going on. So allow me to try to explain. What's going on is that one doesn't want to format. Oops. I should put semicolons. Even though I actually don't have to, I should put them. Because those are the end of statements. So what's happening here is we are checking if it is selected. And if it is selected, then we want to print it in magenta and black. But we still want to have the menu option appear. So if it's not selected, we want to print it in white with a black background, right? That's all we're saying. So we print 3 menu options, and whichever one is selected is magenta, the others are white. So we do need to check all 3. We need some way to know which one is and which one is not selected, or which ones are not selected. So next, we're gonna match on the key. So that's how we're reading input, right? So we're going to return main menu result, no selection, and then we return whatever is currently selected. So I did kind of call how this is going to work earlier, where this, despite the fact that we have no selection, oh wait, if I save, that's going to format anyway. Yeah. Despite the fact that we have no selection, we still have a selection, or rather something that is selected, right? Selected is not the same as us actually selecting something, if that makes sense. Selected is like, you know, imagine you have some options in a menu and you're using your arrow keys or WASD to scroll through the options, and one of them is highlighted. That's what we're talking about in this case by no selection, but something is selected. And then this right here is where we actually select which option we want to commit to. So we're going to match against the key. And we are gonna say virtual key code escape. It's gonna be return main menu result, no selection, and selected. We're quitting, okay, yeah. That's easy enough. So what's next? Where's the end of that? I have to keep scrolling this thing like 2 different directions. It's too wide to fit on the screen. So I have to keep scrolling in a bit of an annoying manner to see the entire lines. So what are we gonna do next? Up. We're going to copy that line for down and return. Alrighty, up, down, and return. And I think these are going to be very similar, these first 2. New selection, match selection, main menu selection, new game, new selection, equal main menu selection quit. This is where you got me wanting to argue, why don't we just return a value out of the main instead of, well, doing this? Why are we setting it equal in here when we could just flow it out of the match? I don't know. Is it really any different? No, but How the compiler might even optimize that because it's so simple. So there we go. And then we return main menu result, no selection, new selection. So then we're probably going to do like basically the exact same thing here. But it's going to be a slightly different order. That's my guess. So new game is going to be load game. You have to just envision what we're going to be seeing at some point. Load game becomes quit. And then this becomes new game. So what we have to envision here is, like, how does this map out? So if we're pressing up, we're cycling up through the menu choices. So above new game is quit, which is probably going to roll it around to the bottom. Quit's going to be the last one. And we can see that here where quit is 26. So that's the lowest. And oops, I missed this one. So new game up goes to quit. From load game, it goes up to new game. And from quit, it goes to load game. And then vice versa here. From new game, it goes down to load game goes down to quit. Quit goes back up to new game. So that's straightforward enough if you ask me. As for the return case, we return main menu result, selected, selection. And then for everything else, meaning the user pressed something that we don't process, we do main menu result, no selection. It's basically the same as hitting return. And then an if may be missing an else. I might have done something goofy somewhere. No. After the main menu result, no selection. Main menu selection, new game. I have to think about how that fallback there is going to work. Basically, if none of this happens, nothing here returns, then we do a new game. So I'm actually going to just do one thing as a sanity check. I'm going to copy their code over mine to make sure I didn't make any silly little errors. Okay, yeah, that's totally what they have. I have to think about how this is going to work. Basically, what are the return paths from here? Well, if the run state is main menu, and we with some kind of selection, we're going to grab the selection. Then print a menu, and we match on a key. If they don't press a key, no, if they press an invalid key, that's not pressing a key, right? That's pressing an invalid key. I would think so. Maybe I'm wrong. I would need to see how the keys... So what I'm curious about is I would need to see how the keys are being processed. Does no key also give us an event? Virtual key code. I don't see a, like a no op, like a nothing. So I'm not actually sure what happened, because it seems to me like if it... Oh, wait. No. Yeah, because this if let happens. This is the if let. And from the if let, that's not in an else. So if no selection, if we don't have this match here, then we just start a new game. Now, granted, we're in control of when we call the main menu. So we can set the run state before we call main menu. So we should know what's going to happen here. We should know we're always going to have something that this can match against right here. But I find it odd that our default fallback state is to start a new game. Or no, it's to say, oh, wait, no. No select, oh, wait, okay. No selection. Yeah, again, okay. We're not saying that we actually selected it. We're just setting, okay, that's fine. We're setting it to say we're highlighting new game, but we haven't actually selected it. Okay, that had me worried. I hope I didn't make it too confusing, because I was confused there for a moment. But it's because we're doing a result of no selection, but we're selecting new game. Again, it's the weird way, like this no selection versus selected part is the important takeaway. No selection basically says we are highlighting whatever this is, which is new game. We're highlighting it. That's all. We're not actually doing it. Okay. Sorry about that hang up there, but we got to make sure we understand what we're typing. All right, so that's a bit of a mouthful, but it displays menu options and lets you select them with the up, down keys and enter. It's very careful to not modify state itself to keep things clear. So including Serde. Serde is pretty much the gold standard for serialization in Rust. It makes a lot of things easier. So the first step is to include it, and your project's cargo.toml file will expand the dependencies section to include it. So there's a bunch of features as well. I'm going to see if I can just copy these, plop them in there, so we'll have the same versions. Actually, I don't know. We'll see. Let's plop into here real quick. RLTK version. We'll do 8.1 specs. 16.1 is the same. Specs derive, we already have. And then we'll get those versions of Serde. Now, I want to stick with the versions that are closest to what they have. That way, we don't run into any oddities between like API changes or something. I don't know if Specs has done anything like that. I don't know if Serde has done anything like that. But I know, for example, the RNG crate. If you're doing random number generation, there was a change in the API. I don't quite remember what it is anymore. But the way I discovered it was with OpenAI's GPT-3, the text completion. Text completion is the word, but the whatever you call it, the GPT-3. If you give it code or you tell it to write code, like write a Rust function that does this or write a Rust program that does that, and it uses random numbers, it's relying on old training data from when it was actually trained, and the RNG crate has a different API back then than it does now. Because I actually tried running some of the code and it failed, and the thing that stuck out to me was that the RNG crate, the function that was being called from the crate, it was saying, like, I think it used to take 2 parameters and now it takes 1 or something. Or maybe it's the other way around. Whatever it is, that was what like tipped me off as like, oh, it's a different number of parameters. And I went and looked through the different versions of the crates and actually found the old version and then just swapped out the dependency from a new one to match the older one that lined up with what GPT-3 was trained on. So it was a pretty interesting way to encounter that. Okay, so yeah, it says it may be worth calling cargo run now. It may take a while downloading the new dependencies and all their dependencies and building them for you. Should keep them around so you don't have to wait this long every time you build. It's not too bad on my machine, but it could be a problem, I guess. See that I had just enough time to take a drink of water. I wasn't stalling or any... Oh. That's no good. You know what, though? We haven't fully implemented things yet. So let's not fret on that. If we have that bug later, I'll work into figuring it out. I'll work on figuring it out. No, actually, shouldn't we be displaying the menu? How curious, yes? Run. It pops me right into the game. Oh, you know why? Our run state is never being set to the main menu, is it? Where's our run state? Yeah, it goes straight to pre-run. This is an odd bug, however. I've never seen that one. It's clearing things too. So if I go over here, it doesn't do it in the FOV, but it's doing it outside of the FOV. We have a painting tool. We've inadvertently made a painting tool. Well, you know what that means, right? No, I'm not going to draw something inappropriate. All right, we'll look into it in a little bit. If I'm still having the problem, I'll compare and contrast some of the code. We're going to focus on this here because this is what's really important right now, and then we'll look into whatever's going on with that. Again, it might be something that's going to be fixed as we go. So adding a save game state will extend run state once more to support game saving. Are we going to do it for loading as well? Because we might as well do both. Oh. Whoops. Sorry, there we go. Yeah, okay. So where is run state again? Save game. In tick, we'll add dummy code for now. What I think it is... Oh, I'm drawing the map like twice. Yeah, actually, let me scoot back up and double check this, because when I was scooting things around, I think I did make a mistake. Yeah, we're not doing that there. Context.clear screen. And then we were drawing the map twice because I scooted things around and did goofy stuff. I think that'll fix it. Cargo run. Yep, that was all. I wasn't clear in the context, and I was also drawing the map twice for no reason. Cool. Easy fix. As we started looking around, it made itself known very quickly. All right, back to this. Now it's mad. We need the case for save game. To do is fine. We could leave it there, but they put some dummy code for the moment, which is... Scroll back down. Save game. New run state equal run state main menu. Menu selection, GUI, main menu selection, load game. Alrighty. So I do understand why it's a little bit of a pain having to do GUI. to reference the main menu selection, but the main menu is all actually handled in GUI in the main menu function. So we want to keep that more localized to where it's being used. And this is just a way to set this value that's being referenced there. So in player.rs, we'll add another keyboard handler, escape. Alrighty, player.rs. I will look for the virtual key codes. Escape. And we're going to say save and quit. And here we're going to do return, run state, save game. Alrighty, easy enough. If we cargo run, we can now start a game and press escape to quit to the menu. Yeah! Ooh, begin new game works. Load game also works. Quit also works. Now, new game and load game actually do the same thing, if you recall, but they both are working. We actually very easily, like, we have a working menu now. To an extent, we have an actual menu. I'm holding down and I can keep pressing down and we go down as expected, and go up. Very, very cool. And if I hit enter on that quit option there, it'll quit. I can also probably hit escape. Oh no, it takes me to quit. Okay, and then I hit enter. That works. We programmed that in GUI, I just didn't remember. So if I press escape, yeah, it just selects quit. Okay, it doesn't actually quit. Yeah, it's a no selection. We could change it to a selection and actually have it just force quit, but nah, we're good. Okay. So let me make sure I didn't do that one wrong. Yeah, they did no selection as well. Or wrong, it's all subjective. Okay. So we added that for escape. We can cargo run, we can escape to the menu. That's all cool. So now we're going to be getting started with saving the game. Now that the scaffolding is in place, it's time to actually save something. So let's start simple to get a feel for Saturday. In the tick, as an aside, if you go back and watch my first few Rust coding streams, they're all on YouTube. If you watch those, I use Saturday almost every time. Saturday is extremely useful. What I typically do is use it for config files. I know that there are config crates. I find it easy to just use Saturday. What I'll do is I'll define a config struct and I'll say these are all the things I want like passed into my program as a config. And then what I'll do is I'll often build one out in my code. Like I'll actually just create a struct like normal. And then I'll do something like what you're seeing here, where I'm going to turn it into a string. I like to use YAML these days because I just find it more pleasant than JSON. But whatever it is, you could do YAML, you could do JSON, you could do TOML, you could do all kinds of formats. You turn it into a string, and then you write that string to a file, and that's like now a file that you could load in and do the other way around. You could, so that was serializing it to a whatever kind of string. I'll say YAML in my case, or JSON in this case. That's the serializing part, and then what you do is you can take that file, read it in as a string or as like a buff reader or something, and then you can deserialize it. You'll do from string, and then it'll actually you can convert it back into that config struct, and then you can get whatever values you want from the config struct. And then now that I've created that one, like that was an easy way for me to create and save one to the disk that I can then load. I delete the code, or I actually manually create one in the code, like in code. That's just a way for me to get that thing in a file instead of having to type it out in like the JSON or YAML or TOML or whatever format, because I find it easier to just write Rust code and have it make that YAML file for me. but maybe that's just me. But I use Saturday a lot. It's probably my most used crate. I think it is at this point my most used crate. So anyway, in the tick function, we extend the save system to just dump a JSON representation of the map to the console. Alrighty. So let's go to let's go here and let's look for save game. So we have all this hold on. What am I looking at? Okay, yeah, we are still on that. Okay, good. So we're gonna say let data equals Saturday JSON to string, and then it's gonna be and.self.ecs.fetch map.unwrap print line. Is this going to fail? That's my first question. It is, because serialize is not satisfied. So we're going to, I guess, implement that on map, but I was wondering, and this may be possible, but I don't know. So map, like we have, we built this map struct, and then we took some traits and implemented them for map. I wonder if it would be possible to then automatically derive serialize. I don't think you could do that. I was gonna say, I wonder if it would be possible to like automatically derive serialize for something that meets certain trait bounds, but I don't think you could do that. So yeah, we do have to derive it ourselves, and we're gonna look at how to do that. What's going on, Tusk? Hope you're doing all right. So then it says we'll need to add an extern crate Saturday to the top of main. I don't think we have to do that. I don't do that ever. I think that's an older Rust thing, so we're not going to bother with that. So we're going to go to the map code here at the top of map. We're going to add Saturday serialize and deserialize. Now we do need those. Actually, I could be lazier about it. We can go to the pub struct map, and we can do derive. We're going to do default serialize. Oh, it's not showing up. Deserialize clone. Oh, maybe that would help if I did the correct thing as well. Now, can you find it? Import Saturday, serialize, and deserialize. Good to hear you're doing okay, man. And then we have some problems that tile type is not serializable and stuff, so we're going to have to go through this. But there's also some interesting stuff here that I've not seen before. So tile content, skip serializing, and skip deserializing. I don't like that that's, I think, yeah, we'll fix it in a moment. I don't like that those are white. It makes me feel like it's not working, and it's probably getting stuck on this stuff here. So we're going to go to tile type here. So we have partial EQ, copy, clone. We're going to bring in serialize and deserialize. And then for rect, we need to actually go in here and do the same. Partial EQ, copy, clone, serialize, deserialize. If I can type. And that's about it. So there's a lot of things going on here, but I want to break down real quick in my own words what's happening. Serialize and deserialize are traits from Saturday. If something implements serialize, it can be serialized. And then there are all these other crates like Saturday JSON that use things based on their traits. So they say, oh, this thing has serialized, then I can do that. I can serialize it, right? It takes generic with a trait bound of serialize. And same for deserialize. So then we can take serialize, turn it into a JSON, turn it into TOML, turn it into YAML, whatever we want. And then we can do that vice versa. We can take the YAML or whatever, turn it back into our struct map right here. So that's what we're really doing here. And you can see it's proc macro. So there's two types of macros in Rust. There's declarative macro, which is done with a macro called macro rules. And you see it gave me this little snippet here. And macro rules, what do you mean you can't find macro rules? New macro. There we go. So we've now made a new macro called new macro, and we could call it just like any other macro, like that. Now it's not going to do anything because we literally didn't tell it to do anything. But macros, declarative macros like that are made with macro rules, they work on pattern matching and they generate code, and they're extremely powerful. They're not like macros in C or C++. So an example is, I can actually pull up the browser here, and I'll answer you in just a moment, Tusk. Rust Atomic U32. So if we go to Atomic, this is just an easy way to get to it. There's something called atomics, which are these data types which can be safely shared between threads. There's like atomic U32 and I32 and 64 and all the different atomics, right? So if we go to source, we can actually see how the atomics are made. And we see this atomic int here. This is actually a macro. And what's crazy about it is, as I was saying, macros are extremely powerful in Rust. And I'm going to scroll and scroll and scroll and scroll until we get to the top of this. Macros are extremely powerful in Rust. And as with like pretty much any macro in any language, it is a way to generate some code. But you can kind of take it to an extreme here in Rust. And what we see here is this atomic int macro being defined, because we're using macro rules, just like I just showed. And then it goes through and it actually generates a struct. It generates a pub struct called atomic type, which is this $. It's a variable. And basically what you're doing is you're pattern matching in this macro. And what we're doing is all of these things here are like the different pieces of the pattern and everything that you're going to be matching against. So it's very complex. I'm not even going to start breaking any of this down. But what it comes down to is we're just making a struct with an unsafe cell in it with the type. And then we're doing a bunch of implementations and stuff for it. So we're impl const from some type for the atomic type. We'll impl the debug print for it. We'll impl sync for the atomic type. We're doing just a regular impl block on atomic type and putting a bunch of extra functions on it like new and get mute and so on. So this is all done in a macro. It's generating an entire struct and a bunch of functions on that struct and an impl block and different derives and everything. So macros in Rust are super powerful. That's one example of what you can do with macro rules. That's a declarative macro. So back to the reason I got brought up onto this topic is this here. It's a proc macro, a procedural macro. And these essentially take Rust code and manipulate it to produce more Rust code. So it's still a way of writing code that makes code, but instead of operating on a pattern, it operates on actual code. So you'd see that with derives, because what's actually happening with derive is, now this just says macro here, but I think, yeah, so I think the built-in ones are just going to say macro, but the ones that are implemented like from Serday, for instance, are going to be procedural macro. And so like when you see derives, it's a procedural macro basically, because they're able to take the struct here, read it into the procedural macro and build out all those impl blocks and stuff on it, or whatever it actually takes to do serialize and deserialize. So that's a big like aside there, but it's very powerful. And this is, I think, the first time. No, we've done a couple. I didn't really get into it before with components, but for some reason I was in the mood to talk about it today. But component is also a proc macro, as we can see here. So we've been deriving component for everything, and now that I've talked about kind of what it is, we can see it's just a proc macro. And I'm not going to get into that like I just got into the declarative macro, but just take my word for it for now, because they're actually a lot more complex. Declarative macros are pretty complex too, but proc macros are another beast. So something is mad here. Okay, we'll have to take a look at that. And I got a chat message to respond to in just a moment. Let me double check this code here. What did I miss? Oh, I just typoed it. I always make that typo when I'm talking for some reason. So Tusk asks, could there exist games where you need to code? There are games where you can code. There's a handful of games where you can code, and they're done in different ways. So there are some games like Human Resource Machine, which is basically a kind of assembly language. It's very basic, rudimentary coding, but I don't quite remember exactly how the gameplay works, but you have a basic set of operations you can do, and you can like set them, link them together, and build basic loops and stuff, and solve the puzzles on each level basically by building out a little algorithm, a little piece of code that satisfies whatever like puzzle you're trying to do. There are other games which have more conventional coding. There's actually a game called Screeps, where it's like an online, it's like an MMO. It's like an MMO kind of. You have a big map, and it's almost like a real-time strategy, but driven by code. So what you do is you write code that like tells your nest or whatever to spawn dudes, and it tells them what kind of dudes to spawn. And the dudes are made up of different parts, so you can add like multiple moving parts on them to make them faster. You can add multiple combat parts on them to make them better at fighting, and so on. So you can add these parts to your creatures when they're being spawned to make different kinds of creatures. And you need to have creatures that go out and gather resources and bring them back, so you can keep building more creatures and building better creatures. But it's all driven by code. And what your objective is to basically build out your build your nests and stuff as large as possible, gather as many resources, take over as much of the map as possible. But again, you're doing it all by code, like real code, not like a thing that they necessarily made up for the game. The game uses JavaScript, but it has Rust bindings. You can write Rust code that commands and creates and like does all the stuff with your creatures. But you're also doing this competing with other people. So there's an interesting nature to that. But there's quite a few games that are based around code. But that's probably the most like hardcore example of like, no, you really just write code, like just write JavaScript, Rust, whatever, like just straight up write that code and it controls everything about your game. Really cool stuff. So yeah, there are games that are based around coding. Hope that was a satisfying answer. So I've done all the stuff here. You could potentially learn coding, yes, but a game like Human Resource Machine, you would learn basic like assembly language, which is actually not a bad thing. It's I mean, those are extremely important foundations and fundamentals. And it's kind of nice because it takes you down to a lower level, just the simple rudiments, like rudimentary nature of programming, where it's like you don't have like a normal loop, but you can say go back here. So that builds up a loop, right? Instead of having like an actual loop that you have in code here, where it's like for I in 0 to 10 or 11, whatever. Instead of having a loop like this, you have to be a little more explicit about it and build it up yourself, which is like what you're doing in assembly language. So then you would have like let mute I equals 0, and then you would be like do something, and then you would say I plus equal 1. So now I is 1, and then you would say go back to do something. And then you'd also check like if I is less than 10 or something, right? If I is less than 10, do something. And then I is plus equal 1. And you say go, well, instead of go back to do something, go back to if. And that's kind of like how you build a very simple loop, right? Because then we started at 0, we do this check, we do some work, we increase it by 1, and then we go back and do the check again, and then we'll say else go somewhere else. Like whatever, right? If I can type today. So this is more of like what you're doing in a game like Human Resource Machine, and that's kind of akin to what you're doing in assembly language. You have to build everything from like the basic building blocks, but it is actually an interesting way to learn because it's disguised as a game. You don't really think about it as programming. It just feels like logic and puzzle solving, and it turns out, oh, you're programming. You actually are programming. A game like Screeps, I wouldn't say is a way to learn programming, because it's a bit too complex, I think, for a newcomer to just jump in and be like, I'm gonna write all this code that, you know, controls an entire like base of dudes and spawns them and sends them out to gather resources and fight other players and stuff. I don't think that's a really good place to start as a new programmer. But I mean, it's not a bad goal, but I think it's a bit much to like start with that because there's so many fundamentals you'd be missing. Alrighty, so back on this now, because I took a big tangent there to talk about declarative and procedural macros, and I was answering some question there. So let's get back on this now. So we've got the run state in and everything. I think we're all happy there. We don't need extern crate, despite the fact that it says we do. That's an older Rust thing that was removed in like 2019 or 2021. I don't remember. And then the code won't compile. So I'll actually click in here. So I've already done it, but it's like this code won't compile because we need to tell map to serialize itself. Fortunately, Serday provides some helpers to make it easy. At the top of map.rs, we use Serday serialize and deserialize. We then decorate the map to derive serialization and deserialization. And these attributes like this are actually inspired by this thing here, these derives are actually inspired by C# attributes, like according to the Rust spec from like years and years ago. Just a note. Note that we've decorated, and also I'm not saying they're the only language that does something like that. Python and Java both have things like that, I know, but whatever. Note that we've decorated tile content with directives to not serialize and deserialize it. This prevents us from needing to store the entities, and since this data is rebuilt every frame, it doesn't matter. The game still won't compile. We need to add similar decorators to tile type and rect. So I've done that as well. So one thing to note is when you are deriving serialize and deserialize, everything in a struct must be serializable and deserializable. So most of it was fine. I32 was fine for the width and height. The revealed tiles, invisible tiles, and blocked are fine because those are just Booleans. Those are primitive data types. And a vector of Booleans, it's fine. It knows how to handle that. But a vector of rect and tile type, it doesn't know what those are, right? So that's why we had to do that for tile type and rect, because those are custom data types that we made. Primitives already have serializable and deserializable implemented for them. I don't even know if the primitives really need it implemented, but things like vec has it implemented. Okay. So now if we cargo run, when we hit escape, it'll dump a huge blob of JSON data to the console, and that's the game map. So let's take a look at it. So we can walk around a little bit and then grab that and then hit escape. And that's the huge blob of JSON data. It's popped up in the back there. Literally, that's unreadable to us for the most part. But what we can see is, I'm going to highlight this here, rooms. So these are actually, this is the code for the rooms. And then look at this, revealed tiles. So all this false and true and stuff here at the end, this is just which tiles in the game have we revealed. So if I wanted to, like if we save this to disk and then we load it back in, I could go modify any of this I want. I could change any false to true and we've suddenly revealed it on the map. I could change any of these walls and floors around to modify what the map looks like. I mean, that's really it. Like, I mean, it's just a raw representation of every bit of data that makes up our map. So, yeah, that's fun. Tusk asks, wait, how do they make a game if you can code in it and you know too much? Does that mean you can also make... No. So in games like... So in Screeps, where you're writing like real code like this, you're doing it through an API, and the game only understands things through that API, an application programming interface. So what that means is when you write some software and you want other people to use it, you write an API, and that's a set of like functions and stuff that you expose to them. And you say, if you want to talk to my software, here's the API that you can use. So if you want to spawn a thing in the game, use this code here to spawn something. So you have to go through that API to make something happen. So if you're just writing other code, maybe it's doing something on your end, but it's not doing something in the game. So then when you try to run the code in the game, like you run a bunch of stuff on your end and it's like, all right, I got something for the game. If you give it something it doesn't know how to work with, it's going to throw it away. It's going to give you an error or something. So you have to give it something that it understands how to use, and it's set up in such a way where it only understands what it cares about. As for another game like Human Resource Machine, I mean, that's using a very specific set of instructions that are, again, just within the confines of the game. So, I mean, the stuff in like Screeps, like you have no code initially. So yeah, like none of your stuff does really anything until you start writing the code. I don't know if that answers your last question there. Alrighty. So we got what we expected. We got all the data popping out of the console. It's ugly, but it is what we expected. And here it is, a huge blob of JSON data to the console. That's the game map. So now we're going to save the entity state. Now that we've seen how useful Serde is, we should start to use it for the game itself. This is harder than one might expect because of how Specs handles entity structures. Their ID number is purely synthetic, with no guarantee that you'll get the same one next time. Also, you may not want to save everything, so Specs introduces a concept of markers to help with this. It winds up being a bit more of a mouthful than it really needs to be, but gives a pretty powerful serialization system. Yeah, I wonder if there's a way, if it's going to tie things to, I don't know, we'll see how it works. Introducing markers. First of all, in main.rs, we'll tell Rust that we'd like to make use of the marker functionality. So use specs save load, simple marker allocator. In components, we'll add a marker type, serialize me. Back in main, we'll add serialize me to the list of things that we register. So it's a marker though, so we're not registering it like a component. Okay. We're registering it as a marker. We'll also add an entity to the ECS resources, which gets used to determine the next identity. All right, I'm gonna have to see how this one works. Let's take a look at it. Because I'm already like reading multiple steps ahead, and it's like, we'll see. Let's start using some of this. Let's use specs, save load, and then it's simple marker and simple marker allocator. In components, for once we're not actually deriving component because it's not. Serialize me. Okay. And then back in main, we'll add serialize me to the list of things that we register. So I'll just go to the registers and plop it on the end, even though it works. Oh, I'm not in main. No wonder. I was like, where is it? This isn't right. I'll just plop it here on the end, but it's going to be simple marker serialize me. And simple marker, let's read it. Basic marker implementation usable for saving and loading. Uses U64 as identifier. Okay. So we'll add an entry to the ECS resources, which gets used to determine the next identity. Okay, so gs.ecs.insert. Simple marker allocator, serialize me, new. So what is this simple marker allocator? It just says a basic marker allocator. Okay, we're gonna have to see how this fits together then. In spawner, we'll tell each entity builder to include the marker. So the complete entry for the player. Let's check out spawner. So create entity with. So the last thing we do is mark it. Marked simple marker serialize me. So it's literally just okay. It's literally just marking it, which of course, but do I include it? Yeah, we'll import that. Okay. Add a marker to the entity by fetching the associated allocator. Okay, so it's looking for the allocator. This is a bit odd. But I mean, the way I'm interpreting it now is you're just marking it to say, hey, this thing is going to be important for when we save or whatever. We're going to see how it gets used. So not much changed there. And we need to repeat that for all of our entities. So it says, create entity. We're going to go to the first one and we're just going to make sure that we got it. So I'm just going to plop it on the end. And here, and here. So they're all marked. Yeah. So all the stuff we're spawning is now marked. And the tutorial text here says, the new line marked simple marker serialize me needs to be repeated for all of our spawners in this file. It's worth looking at the source code for this chapter. To avoid making a huge chapter full of source code, I've omitted the repeated details. Oh. You know, that's fair, Tusk. And at that point, like, what are you supposed to do? Get the wrong food, I'm gonna eat it anyway. I don't mind. As long as it's something I'll eat. I appreciate that. The convert save load derive macro. So okay, so this is a specs macro, I think. I'm pretty sure. Yeah. Well, we'll see. Yeah, I know it is. Okay. The entity class itself Actually, is derived macro is a procedural macro. We did see proc macro. I hope I wasn't spitting lies. Oops. Rust derived macro. Yeah, see, the first thing we see is procedural macros. Proc macro. Good. The convert save load macro, the entity class itself provided by specs isn't directly serializable. It's actually a reference to an identity in a special structure called a slot map. Basically a really efficient way to store data and keep the location stable until you delete it, but reuse the space when it becomes available. So in order to save and load entity classes, it becomes necessary to convert these synthetic identities to unique ID numbers. Fortunately, Specs provides a derived macro called convert save load for this purpose. It works for most components, but not all. It's pretty easy to serialize a type that doesn't have an entity in it, but does have data. So we go through all the simple component types, and they do position here, but again, ones without entity. So we want to make sure convert save load is on all of those. That's what I'm reading, so we're going to go for it. Let's just go to the top. And this also has clone now for some reason, so we'll do it. Cannot find derived macro serialize. Bring in serialize and deserialize. Fail to resolve the use of undeclared type convert save load, because we should probably bring that in too. No? Let's see. Use of undeclared type convert save load. Convert to specs save load, convert save load. Could not find. Why not? Let me do a cargo build. Consider importing. Well, I was going to, but I tried to. I was actually going to, but when it just failed on the last thing I tried, I thought there was something wrong. Cannot find trait marker. Okay. Marker. No error. Dude, why do we need so many things? Do I just need the... I have the specs prelude. You know what, let me go check their code and see if I'm missing something. Okay, no, that's the last one. Use specs, error, no error. Okay, that was the last one, so we're good. All right, so we have component. Do I need clone? I don't, but they have it, so I'm gonna put it. Renderable. It has no entities, but I don't think we need. Maybe we do. Okay, so yeah, for everything that doesn't have an entity... Hold on. I don't know, I'm just gonna go ahead and start putting these on and see what happens. Let's see what happens. I've never done this before. So one without data, we have to do serialize and deserialize. I am seeing that right now. So serialize, deserialize. We'll try one in a minute. Convert, save, load. So we'll try convert, save, load here. I guess it's gonna, yeah. Parameter MA is never used. Okay. I don't know what that is, but not default. So what if I do convert, save, load on this entity? Okay, it seems happy. Suffer damage, serialize, deserialize. Provides healing, convert, save, load. Serialize, deserialize. Oh no, this, why did I do that? It's convert, save, load. And once again, so many. This actually cropped up in one of the previous sections. Convert, save, load was actually on one of the derives, and it failed because we didn't have it included or anything. We weren't working on this stuff yet. So serialize me, I don't think needs it. So here we go. All right, let's take a look now. I think we're good. So yeah, it says pretty easy to serialize. So this is why I put it on all of them, even with entities, because we still want to serialize it. So it's pretty easy to serialize for a type that doesn't have entity, but does have data. This is we mark it that way. So we'll go through all the simple component types. Here's position. We derive, convert, save, load, boom. So what this is saying is that the structure is a component. You can replace this with writing code specifying spec storage if you prefer, but the macro is much easier. Convert, save, load is actually adding serialize and deserialize, but with extra conversion for any entity classes it encounters, which is the reason I put it on ones that included entities. I feel like the language is a little misleading because it's, again, let me read this and be clear. It's pretty easy to serialize a type that doesn't have an entity in it, but does have data. Mark it with convert, save, load. But that also makes it sound like you can't do that if it has an entity in it. But here it says convert, save, load is doing serialize and deserialize, but with extra conversion for any entity classes it encounters. So I guess we should put it on entities, on ones that have entities. Clone is saying this structure can be copied in memory from one point to another. It's necessary for the inner workings of Serde and also allows you to attach .clone to the end of any reference to a component and get another perfect copy of it. In most cases, clone is really fast, and occasionally the compiler can make it do nothing at all. So we need to go back and put clone on all those because I didn't read that part. So if it doesn't have clone, let's put clone. I'm just gonna go put, oh, we got double clone. Getting into Metal Gear territory. Just clone everything, right? We're still kind of happy. Oh, we did double clone. Alrighty. Next. When you have a component with no data, the convert, save, load macro doesn't work. Fortunately, those don't require any additional conversion, so you can fall back to the default Serde syntax. Here's a non-data tag class. And it's this player one here with serialize and deserialize. So actually saving something. The code for loading and saving gets large, so we've moved it into saveloadsystem.rs. Then include a mod save load system in main.rs and replace the save game state with some blah. All right, well, let's take a look at it. We're going to say save load system.rs. And then in main, We're going to do mod save load system. Now we're going to go to the save load system. Oh, actually, no, first we're going to go to this here. So instead of that stuff there, we're going to say save load system, save game, and mute self.ecs. So it needs the game, it needs the world so it can save it. And we don't have the function yet, so I'm going to be a little lazy, have it generate that. We'll get rid of the crate on the pub there. And I don't know if we're going to return anything, so we'll see. So on to implementing save game. Saturday and specs work decently together, but the bridge is still pretty roughly defined. I kept running into problems like it failing to compile if I had more than 16 component types. To get around this, I built a macro. I recommend just copying the macro until you feel ready to learn Rust's impressive macro system. And we get to do macros. I actually did see this the other day, and that's part of the reason I actually kind of forgot about it until sometime during this session. But I was like, didn't we read about macros in this lesson or the next? And yeah, it was this one. So we're going to do macro rules, and we're going to do serialize individually. Serialize individually. Let's make sure I can spell. And then again, macros are about pattern matching. So ECS, EXPR, SER, EXPR, data, EXPR. So what we're doing here is we're basically making variables that live in this macro, in this pattern. And what we're doing is we're saying what these variable types are. So let me explain. I'm not trying to proclaim to be the best at macros, but I have made a few macros, and I think I can at least explain what's happening here for the most part. So $ECS is a variable. $SER is a variable. $data is a variable. And $type. I think, I don't remember what TY is. Oh no, I guess TY is the type. Oh, we could also look at macro rules maybe and get some extra help. Or not. Nah, it's mad. Okay. Yeah, I was hoping if I mouse over macro rules, it would tell me a bit. So anyway, ECS, SER, data, type, those are all variables, those $ names. And then the colon and then the thing after it, EXPR, says ECS is an expression, SER is an expression, data is an expression, and this type is a TY. Again, I think that actually is a type. And I'm not sure how this $ is going to be used. And the star, I think that's saying that we can have as many of these as we want, because again, it's a pattern. But I'm not 100% on that. We can look into some of the rules in a minute to break it down. Again, I'm not proclaiming to be the best at macros. I've only written a few. So serialize, oh my God. If I like mess up typing serialize, I have to like stop and start over. The word just breaks my brain. So what are we doing in here? Simple marker, serialize me. Serialize. And then down here, we're going to be using some of these things from this pattern again. So what I would basically say here is you can almost think about this pattern, this thing here is what we put in the macro, like when we use it. So if I go in here and I say serialize individually, I need to satisfy this pattern. So this is where it's going to happen, is like in here. And then this is the code that we actually generate based on that pattern, right? So the first thing is ECS.read storage type. Okay. And then data.0, data.1. So what we know, we're making some assumptions here on how this data is going to be set up, which could be a problem. So what I would suggest is, if possible, you'd want to like do some enforcement on the data that you have here, because we're basically assuming that this is like a tuple or something that has a .0 and a .1 on it, right? That's what I'm getting from this data here. So I think you'd want to be a little careful about that, because if I pass it something that doesn't have that, this is going to break. Unexpected end of macro invocation. Okay, it's because of this. It's because I'm defining the macro here and it can see that I'm not calling it correctly, I believe. So now, this is a bit of a strange thing here. So again, I might have to break down how that part of the syntax works. But the rest of it is not that bad to me. So basically what we're doing is we're saying ECS.read storage, and then the type of whatever it is that we passed in, we're because it's a generic, so we're actually passing that type into the read storage. And then we're doing stuff with data.0, data.1, and we're getting not $mute and mute. We're getting a mutable reference to this expression, ser. And you get a little bit less help in your syntax here in the macros, unfortunately. So you got to be pretty careful. So hopefully I didn't make any mistakes. And in fact, now that I've typed it, just to be safe, I'm gonna just blah. That way I know it should be accurate now. I just copied theirs over mine. And we haven't used it yet, so we'll take a look at it. But I think we're gonna loop over a bunch of stuff. Yeah, we are. Okay. Very interesting use of it. Okay. So let's go back to this. The short version of what this does is that it takes your ECS as the first parameter and a tuple with your entity store and markers stores in it. You'll see this in a moment. Every parameter after that is a type. Right, because that's what I was saying here, where I think this means we can have as many as we want, the star. So every parameter after that is a type, listing a type stored in your ECS. These are repeating rules, so it issues one serialized component, serialized call per type. It's not as efficient as doing them all at once, but it works and doesn't fall over when you exceed 16 types. The save game function then looks like this. So let's take a look at it. There's a big, beefy thing in there. We're going to take a look at it. So first we're going to create helper, which is let map copy equal ECS.get mute, and it's going to be super map dot unwrap dot clone. So we're not actually taking the original, I guess. Let's save helper equal ECS dot create entity dot with serialization helper. Did I spell that right? Map copy. I don't know what serialization helper is, so we're gonna have to figure that out. Marked simple marker serialize me dot build. Gonna find struct serialization helper. Yeah, where did that come from? We're making a component. Okay. Well, just out of nowhere, you don't even tell me. You're just like, we're using a thing that I haven't even told you exists yet. I was like, what is this? I mean, I guess if it's a dot with, it has to be a component, but still, it's like, what the hell is it? So we'll go to that in a minute. So we make the save helper, and then actually serialize, and then we have a scope here, and this is going to happen in that scope. Let data equal ecs.entities, ecs.read storage, and it's going to be simple marker serialize me. So what I think that's saying is, yeah, get us everything that has that component, right? And this is the special marker one. So it's everything that can be serialized via that marker. Okay. And that actually makes sense because we don't necessarily want to save some components, I guess, but... Oh, wow, yeah. Okay, this is going to be interesting. So I'm looking ahead and I'm like, what? Let writer equal file create dot save game dot JSON. Press X to JSON. We'll unwrap. So we just make a file and assume it works. Let mute serializer equals Saturday JSON serializer. I've never done it this way. New writer. So it goes to the file. Ah, and that's probably what we're doing here with this. I've never done it this way, but that's interesting. We need file imported. Okay, and now we use our macro. And good God, do I want to type this? So it's going to be ECS serializer data position renderable player view position, or no, view shed monster. We're not done. Not at all. Name, blocks, tile, combat stats, suffer damage, wants to melee. Do I need to keep going? Do I actually need to keep going? So I'm not even halfway done. So I think the point is here. We're going to serialize everything. Basically. And I need to bring all these in because I was screwing up. All right, where's it at? You know what? If I just grab these and put them up here, it should work. There we go. That is not a function, that is a macro. It looks terrible. What I'm curious about is data is ECS, ser, and then data is the third. Data is a tuple. Read, okay. Yeah, it is a tuple. So as long as we know that it's a tuple, which yeah, I guess we could see here. We're defining it there. As long as we know it's a tuple, it's going to satisfy that macro. And we need serialized components, which comes out of something. Use specs, there it is. I hope that copied. Yeah. So we need that. We need no error. Use specs, error, no error. Good God. Serialization helper is still not, it doesn't exist. So we need to go to components. And I guess we derive all the stuff for it. Serialization helper, and it takes map, and we bring it in. Import map. Cannot find type map. Use super map. All right. I think that's everything. So let's go back to the save load. What's wrong with create entity? What? Oh, also, I need to register that component. Serialization helper. All right. No method with found on what? Is there a weird typo there that I'm not seeing? Oh, because those aren't imported. There we are. Okay. Good guide. This is a big old beefy boy. So we're going to have to... Anything else that needs to get saved has to go into here, huh? It makes sense. I would like to see how the serialized components serialize works. So let's take a quick look at it. Let's just pretend I'm going to call it down here. Serialize components from specified storages of all marked entities with provided serializer. When the component gets serialized, the closure passed in IDs argument returns none for unmarked entity. In this case, serialization of this component may perform workaround or fail, so the function doesn't recursively mark referenced entities. For recursive marking, see serialize recursive. One moment. That was a lot. So basically for this, we pass in entity resource, storage, and S is the serializer. So serialize, that's the data. Data is the entities in the read storage. We're passing in 4 parameters here. Oh, I know why. Because... Is it because of how we're calling it? Because we don't have a self? Because we're not calling it on something? Maybe? Yeah. So what we have in the macro here is this would be our first parameter. The read storage. Next is our entities, which is this, ecs.entities from data. And then ecs.read storage, the marker, which is this one here. It actually has to be markers, okay. Has to be markers, simple marker. Oh no, it is because this is how we're doing it, right. That's fine. And then last is the serializer, which we could see here. It's as serializer. So we actually know that it's a trait. That's a lot to unpack there, but I think I got it. And then we're not actually returning anything, so that should be good. And that should be it to get this thing working. Alrighty. Oh, one more thing I had to do before we end this. Clean up. ECS.delete entity save helper dot expect crash on startup or cleanup. Why did I say startup? Crash on cleanup. So I still don't know what save helper did. Let's see. Oh, that's just with the serial. It has the map copy. That's just how we get the map. That's literally all it is, huh? Okay. I think I get it. Map doesn't implement debug. Does it need to? Serialization helper need to? No. Okay. We're good. I think. All right. Let's go back and let's break it down. So what's going on here then? Well, we start by creating a new component type, serialization helper, that stores a copy of the map. See, we're using the map stuff from above. It then creates a new entity and gives it the new component with a copy of the map. The clone command makes a deep copy. This is needed so we don't need to serialize the map separately. We enter a block to avoid borrow checker issues. We set the data to be a tuple containing the entity, store and read storage for simple containing the entity store and read storage for simple marker. That's our tuple, yeah. These will be used by the save macro. We open a file called savegame.json in the current directory. We obtain a JSON serializer from Serde. We call the serialize individually macro with all of our types. We then delete the temporary helper entity we created. If you cargo run and start a game, then save it, you'll find a savegame.json file has appeared with your game state in it. So the important thing to note is we're just serializing everything in order. So first we're going to serialize position, then renderable, then player, then, I mean, we're just going to go in order if I understand this right. So, I mean, that's fine. There's nothing wrong with that, but that's explaining how our save file is going to look. So we also have to be able to load it in that same order. That's going to be key. When you serialize something in a complex way like that, you have to deserialize it. It's basically a mirrored thing, right? So we're going to do a cargo run here. Good God, though, that was beefy. Let's see if I can cheat as well. Should I cheat? Of course. All right, I have 22 health. Let's try to remember that. All right, I see savegame.json has already appeared. And see, here's a big old thing here. And so the marker has tied the component together, huh? So if I look around long enough, I should... Yeah, this marker has no components. All the visible tiles, so we know that's the map. $22. That's not working out, is it? I was gonna like say, can I cheat? Is there combat? No. HP? Yeah, here we are. Here we are. See, look at this. Marker 0 components, max HP 30, and there's 22. So I have 22 health. Let's up that. Let's cheat. We'll say I have 44 of 60. We'll say I have 4 defense and 10 power. I'll just one-shot everything. Why not? Oh no, it formatted. I don't exactly want this to format, but it's JSON is JSON. It should be fine even if it's not formatted. Hopefully. If not, I can go back here and undo. I have auto format on, or format on save. So oops, it's fine. Alrighty, I just thought it'd be funny. So there we go. We see our save file, we know that's working. We're getting close to the end, but we still got a little bit to go through here. So we're gonna restore the game state. Now that we have the game data, it's time to load it. Is there a save game? First we need to know if there is a save game to load. In save load system, we add the following function. Does it exist? And we're just gonna build a path and ask if it exists. Very, very, oh, whoops. I was on the wrong thing here, but really it's not much. I mean, I just read that. Not much there that you missed. Okay. Hopefully I wasn't on the wrong thing when I was editing. Okay. I'm not sure if I was, so here we are in the, I don't know if you saw this or not, so here we are, there was a big old file It looked different the first time. But basically we could see markers tying together with components, just in case this didn't show before. And then as you go through, you start to see interesting ones. Like this is obviously a renderable. Whatever 103 is the glyph. And I can look for like combat stats. No, I looked for, you don't see the name combat stats or anything, but you do see the field. So like you see HP, and this is where I changed mine. It used to be 2 defense, 5 power, 30 health, 30 max, 22 current. I just modified that a little bit for funsies. And hopefully this still deserializes, because it used to be a big old block, and I have format on save on, so it actually turned it into proper JSON now, like good looking JSON. But anyway, let's get back to save load system. Let's get that thing implemented very, very quick. Hardly worth even switching away. Hub function does save exist. Bool. Path new, and it's just dot say slash save game.json exists. So we get a boolean back from that if it does exist, and we don't have path yet. Excuse me. So then in GUI.rs we extend the main menu. Where is it at? I already have it open, so I could go there. We extend the main menu function to check for the existence of a file and not offer to load if it isn't there. So at the top, oh my god, this is going to be a pain to parse. Let save exists equals super save load system does save exist. And then what I really care about is where that's being used. So yeah, we're gonna go here and say if save exists, then we'll do all this fun code. I don't think any of that's gonna change. Oh, because we're not even gonna print the option. Okay. And then we're gonna do a little bit of code in here. Or are we? Yeah, it looks like we could still do a little bit with it, but we'll see. I might have to scour this a little more closely. But what I am noticing is before we do the return on new selection here on up, say if new selection equals main menu selection, load game. Oh, I see, we're skipping it. And not save exists. New selection equal main menu selection, new game. So basically if we're on quit and we move up, we're on new game now, and we have no save, skip, go to new game. We need to make it mutable now, okay. Cool. And we're gonna do the same thing here. So we're gonna make that mutable, and before we do this, we're just gonna reverse the order, right? So we're probably gonna go from new game to quit. Oh, no. Yeah, we're gonna go to quit, okay. Because we go from new game down to quit. We skip load, and there is no load. We didn't even print the word. All right, so I think nothing else should change. I'm gonna assume that's fine for now, because that seems in my brain that all fits. So we're gonna go with that for now. Otherwise, I could just copy paste the whole function over it now in case I missed something, but that's disingenuous. Let's see if there are any bugs and we'll fix them. So finally, we'll modify the calling code in main.rs to call game loading. And where is it at? Load game. There's something in here for load. Oh no, we don't have Yeah, we don't have a state for that, but we do it here. So main menu load game. Okay. Now what are we going to do here? Save, load system, load game, and mute self.ecs. And then we're going to do new run state equal run state awaiting input. And I find function. Yep, that's cool. But it's mad because now we need to do new run state equal that. And that one doesn't do a run state. So we now remove match selected. Okay, hang on. Because it wants me to return a run state somewhere. But I don't see where that's happening. Like at all. Oh, wait. No, this is the right, yeah, this is the right one. Let me try something. What if I copy this block and paste over it? Okay, so I'm missing something and I don't know what it is. So let me look more closely. I was making sure that that there wasn't some issue. So let result is the GUI thing. We're going to match on the result. And then no, okay, so GUI main menu result, no selection selected. New run state equal run state main menu. Selected, okay. All that's good. And they just put a comma after it. They didn't even, no? Well, there is a comma there. Oh, it's after this. I have an extra set of brackets because it auto-formatted them in. And then this here. We do a bracket around this. That's the only difference I see so far. Before the match, which will also mean we need one after the match. So he's getting kind of mad. But that shouldn't matter. So GUI on new game, we just say new run state. Oh, whoops, I put an extra one there. That's not good. That helps a little bit, I think. And this one on load, that's what's doing it, isn't it? Yeah, that's what was doing it. All right, sorry that you make those little typos sometimes and you just like glaze over and you can't see it. And especially when you're refactoring with somebody else's code too, it's like your brain just misses obvious things like that and it can be frustrating. Not frustrating, but difficult to see. We're good now. So we need load game. Let's have that generate. And that's maybe going to return something. Not sure. No, we're not going to return. Because we're mutating the world. Okay. So we don't need to return anything. We're going to need another macro though. And it's probably going to be almost the same thing. It's just going to be in reverse, right? So it's going to be macro rules. Serialize individually. And what are the rules going to look like? I bet it's going to be almost the same. So it's an ECS expression, DE expression, data expression, and a list, like as many of these as we want, as many types as we want. And now we do some magic here. Deserialize components, no error. And then we don't care about that one. We'll let it figure it out. Deserialize and mute ECS.write storage with whatever type we're looking at right now. And we'll do and mute data.0, and this is our entries, or no, entities. And mute data.1 is going to be marker, and mute data, not dollar. And mute data.2 is going to be allocator. And mute DE is our deserializer. We do all that, and then we unwrap it. And then we do that right there. Alrighty. I need to break down a little bit of the syntax. So the one that I'm not 100% sure, I think I do understand it though. I think what's happening, I can tell you like every piece of this, except for this dollar here with the open and closed parenthesis with the star, but I think it's this. I think it's saying, I think it's basically a for each on the pattern match, right? That says do this for each type. And we're basically saying whatever's enclosed in this TY is going to represent each type, and it's going to like iterate through that. We could check macro rules after I'm done with this section here and confirm that, because I've never done that in a macro I've written. So I'd like to confirm that that's how it works. Now, just for sanity, because we don't get all the nice IDE stuff, I'm just copy paste what they have in here. Just so if I made a mistake on like $1 sign or ampersand, it doesn't just blow up here. I don't normally do that, but on the macros, we don't get as much helpful like underlining and complaining by the IDE. So I'll do it for that macro there. But I still want to type it. I want to like get used to building out macros more, because I've only built a few. And I never thought about doing one like this, so it was pretty cool. And this is basically, though, this is the same thing we did earlier, right? It's got a little bit more data involved with it. I'll probably take a look at how deserialized components works once we get this function built in, just like I did with serialize earlier with the serialized components serialize here. I'll take a look at that. With this deserialized components deserialize, I'll take a look at that as well. So we just have a little extra scope here immediately. You know, that's great. Delete everything. Let mute to delete equal vec new for e in ECS dot entities dot join to delete dot push. So we're just building up a list, a vector of all the entities that exist, and we're going to delete them all for del in to delete dot iter ECS dot delete entity star delete dot expect deletion failed. I wonder if it would be better, you could pass in delete entities and it takes a slice. I don't know if there's a reason we're doing it one at a time rather than a slice. So that would be something to question, and maybe it'll be explained here in a minute. Let data equal fs read to string. I didn't know about that one. I've always gone about it in a different way. I don't think I've used that one before. So we'll read to string, save game.json. This skips a few steps. You can also use a macro called include stir, and you can put in a file that, and it gives us back a string slice. It couldn't read the file for some reason. Is it going to be this? There we are. The pathing on it's weird. That's why it's probably better to use something like this than the macro, but the macro is helpful. That's probably the quickest way to do it because you don't even have to unwrap or anything, but it'll be like, yo, that doesn't exist. You saw it there. It's like, it doesn't exist. You got to get the pathing the way it wants it. Because right here, this will be fine. This is fine for this read to string, but I had to do the ... / to go back a directory for the include string. So it's weird. Let mute deserializer, or de equals Serday JSON deserializer from string and data. So we just read the data in, and we deserialize, we put it into a deserializer. Now we need a scope. Let mute d equal ref mute ECS dot entities and mute ECS dot write storage. Simple marker. Serialize me. Oh my god. That's a big beefy one. We're not done with this. And mute ECS dot write resource. I wish they would format this a bit more. Simple marker allocator. Serialize me. Yeah, I wish they would format this a bit more because I gotta like scroll it all over the damn place. And now I think I made a mistake somewhere because I can't see what I'm doing. Okay, what am I? And mute ECS.entities and mute ECS.write storage, yes. Oh, I need another one of these. That looks fine. Is it? Oh, it's because we don't have this. Oh, because I auto-completed. Look at that, it immediately formatted. This is what it should look like on the tutorial, in my opinion, because scrolling back and forth like that is not great when it doesn't fit. There's a lot of, that's actually my biggest complaint about the tutorial. There's a lot of really long lines that you have to scroll back and forth to read. So you're doing one line, you have to scroll, and then you got to scroll back when you're done with that line. So that's actually pretty annoying. Deserialize individually. And it's going to take ECS, DE, D, position, and I am not doing that. We're just going to go to position, and I'm going to copy all those because there's no point in me typing every single one of those. And I'd have to scroll back and forth like 3 times. There's no point in me doing that. Again, I don't advocate for copy pasting code from tutorials. This is more of a convenient thing because who wants to type all that if you can avoid it? Now, out of this scope, let mute delete me option entity equal none. So we're saying we don't want to delete anything yet. And then we're going to say let entities equal ECS.entities. Let helper equal ECS.read storage. serialization helper. All right, let player equal ECS.read storage player. Let position equal ECS.read storage position. Let, or no, for EH in entities helper join. I'm gonna have to break down what's going on here because I'm just like on autopilot at the moment. Let mute world map ECS.write resource supermap map world map equal h.map.clone world map tile content vec new super map count delete me sum e. So I see what's happening. We're not quite done here yet, but the map was stored in a special place. It was this helper, right? So we need to actually get that helper and then delete that entity because that's not really where we store the map. That was just a simple place for us to keep it to help us serialize and deserialize it. We don't want to keep it there. So that's the trick to that. Okay. So for E underscore P and position in and entities and player and position. So the only things that we actually need to like do anything with are the entities that, oh, well, we're doing player as well. We're only putting the player in. Oh, because we have a resource and all that. Yeah. Let mute ppos equal ecs.write resource rltk point. So then we'll get the right resource. We'll put a point in there. So because we've done this join with the player as well, we know the only one we're going to get, the only position that we're going to get is the player one. So even though this is a for loop, it's really only going to run one time. Or not right, storage, resource. So we're going to get a player resource now, and we're going to say player resource equal E, which is just what we found here in the loop. So that's all good. And then finally, ECS.delete, delete entity, delete me.unwrap, .expect, unable to delete helper. So I would consider doing, again, unwraps. I want to say it every time we see them. We see them all over here. I want to say it every time, but they're, maybe it would be like, okay, yeah, something went critically wrong here because we should see this happen. Maybe it's fine to crash, but still, I get wary about it. So there's a lot here. We're going to break it down here in the tutorial, but I'm going to do a quick breakdown on this end over here. And the first one I'm interested in is actually this thing here. We need to import that as well. So serialize came in here, so we should be able to, we should be able to bring that in. And that's actually what I'm interested in first and foremost. Where did it go? Deserialize components, deserialize. Let's take a look at it real quick. So deserialize takes a bunch of stuff. It's, what is self? Well, it's a deserialized component, something that implements that trait. Yeah. And then entities, that's easy enough. We're getting that here from this tuple. Next is the right storage of the marker. So that's good. And then the right resource of the simple marker allocator, which is allocator here. So we can see it's just called allocator. And then a deserializer. So, and that's what we get with the DE here. Okay. So we've built all of that out here in the macro, which is this big beefy boy here. And we're saying, here's the ECS, the world. Here's our deserializer. And here is this three pieces. Here are these three pieces of data that we just talked about, right? The entities, the write storage with the marker, the allocator. So all those are being pulled into that tuple, and we're calling that tuple D here, but that's going to be our data up here. So the macro gets the ECS world, it gets the deserializer, it gets that data, and it has, for lack of a better term, it has a list of types. It just takes as many types as you want to feed it. And then we go over all those types and we deserialize each one in turn. And all we're doing here is we're unpacking the data, right? Data.0, data.1, and data.2. What's going on, Ice? Good to see you. I got you. Bloop. That probably went to the mic. Yeah, we're unpacking the data from that tuple, and it's actually labeled here, which is nice because it's a little hard to tell what's going on in the macro. Macros are cool, but they feel like you're getting into a little bit of a dangerous territory because you don't get a lot of your nice, again, this is like pattern matching, right? So you have to know that your patterns are actually good. And Rust will complain if you're, if something, it should complain if something doesn't work. So like what happens if I do this? Yeah, see, it's complaining, no field 2 on type. It is smart enough to see the macro and know that this tuple we're passing it doesn't have a third field. So that's really nice. But yeah, it's a big beefy macro there. It's just going to deserialize everything in turn. What's important is we want to deserialize everything in the same order that we serialized them. I don't think that's been, I haven't read that yet. That's my assumption though. If you're writing a bunch of data to a file, you want to read it back in the same order, or at least know how things map together. So that's generally like the rule, but I don't know if there's some special magic going on here because of the markers. We might be able to get away from some of that. So I don't know. But no, I don't think we would, because I think it is going by the components. I don't know. We'll maybe look at the save file closer later. So anyway, what is happening here? We got the macro to deserialize everything individually. What we do is we delete any existing stuff, any existing entities. We don't need them anymore because we're loading. We need new data. So we throw all of our old data away. All of our old ECS, the entire world is gone. And then we build up that data we just talked about. Well, first we read the data in from the save file, right? And then we deserialize it. So that's our deserializer, our DE. And then we build up that tuple we just talked about, the entities, the write storage, and the resource. And then we feed that into the macro to deserialize everything in turn. And then we say, delete me. And delete me is how we're finding the map. So what we're doing is we get the entities, we get the helper, we get the player and the position. And these are storages, these are components, right? So what we do is we then join the entities and the helper, because that's going to find us the one entity that is what we use to temporarily house our map. So then we get the map out of that entity and we clone it, and we actually store it in the resource where we really want the map to be, where all of our code looks for the map. That's all we're doing. And then we add that entity to the delete me that we made up here, this option. And then, and by doing that, later we actually will crash if we fail to do something here. So in this case, it might actually be a good thing to crash if you fail to load the map. And then, so the other piece here is we get all entities with the player and position component, which is only one. There's only one player. So we then store that entity as a player resource, and we store their position as a resource. And then we delete the helper thing that temporarily stored the map. Boom, that's everything. All right. How's it going, Ice, by the way? Hope you're doing good. Trying to break this function down because it's a big beefy boy. Alrighty. So that was me breaking it down line by line. Let's take their breakdown now. Two different perspectives, and theirs is carefully written as part of a tutorial. Mine is let's just go and read it and figure it out. So that's quite the mouthful. So let's step through it. Inside a block, to keep the borrow checker happy, we iterate all entities in the game. We add them to a vector and then iterate the vector, deleting the entities. This is a two-step process to avoid invalidating the iterator in the first pass. We open the savegame.json file and attach a JSON deserializer. Then we build the tuple for the macro, which requires mutable access to the entity's store, write access to the marker store, and an allocator from specs. Now we pass that to the macro we just made, which calls the deserializer for each type in turn. Since we saved in the same order, it will pick up everything. See? Now we go into another block to avoid borrow conflicts with the previous code and the entity deletion. We first iterate all entities with a serialization helper type. If we find it, we get access to the resource storing the map and replace it. Since we aren't serializing tile content, we replace it with an empty set of vectors. Then we find the player by iterating entities with the player type and position type. We store the world resources for the player entity and his/her position. Finally, we delete the helper entity so we won't have a duplicate if we save the game again. If you cargo run now, you can load your save game. 1 second. I gotta sneeze. It's bugging me. Hold on. Or not. I muted and it's not happening. Okay. All right, we're good. So, yeah, that was that. So if we cargo run, we can now load the saved game. Whoops, why am I saving? I am in the wrong place. Let's try it. Is everything happy? Oh no! We don't start at the main menu, so I'll actually have to go in here. So we made a new save game. I want to try something. I really want to try this. HP. There's that 30 HP. Now we're gonna say 60. I want to cheat because it's fun. 4 power or 4 defense and 10 power. Now will it deserialize if it's formatted like this? I don't know if any of the specs stuff will get mad. But I modified our save file. Oh, whoops. I didn't have the game running, or I didn't have the game showing up. All right, I screwed up. So, I mean, still didn't get to show the block thing here, but it's fine. So we'll load game. Yeah, I have 60 health now. Probably one-shot everything. No, just about. He's unable to hurt me, yeah. What a loser. What a dork. Yeah, so I'm just like invulnerable now and I'm super powerful. It's awesome. It makes me feel good. Everything I ever dreamed of being. Alrighty. Well, there we go. What I want to do is restart the game real quick. Do this. We'll close. Quit. See what save game looks like here. This is what it actually looks like before it gets formatted. Very not great. We can look for HP, and we can find the first component here. Marker 0, components with 30 health, and this is me. I just know that because I know what our values are set to. But yeah, it's a, a mess to look through. It's a mess to parse, but here it is. It's our entire game serialized into a save file. And then, if I go back to the HP and I change this again, I go 60, 60, and we'll say 4, and we'll say 15. No, definitely, well, maybe, no, we'll say 20. I'll one-shot everything because I have 16 health. I save, and it formats. That's what I was referring to, like auto format, format on save. It's nice, but sometimes a serializer may not be expecting new lines. That could be a problem. So there may be cases where format on save could be detrimental. Alrighty. So we're at the tail end here. Just add permadeath. It wouldn't really be a roguelike if we let you keep your save game after you reload. So we'll add one more function to save load system. Delete save. And we'll add a call in main to delete that after we load the game. So we delete, interesting. We load the game, then we delete it. I think it'd be better to do that when they die, because what if the game crashes and your save is gone? I don't really like that. If I were writing this myself, or if I were going to modify this later on, I would change how this works a bit. I don't think, if the game crashes, you should be punished. But, that's fine. It's fine. That's how they want to be. That's how they'll be. The tutorial gods have spoken. So we're going to make delete save. We're going to say if path new, and we're just going to do /save game .json .exists. And we're going to do stdfs remove file. I've never used that one. And it's going to be /save game .json .expect. And what are we expecting? Unable to delete file. There we go. I hate to do this because we're like right here at the end, but I really have to go blow my nose. Give me like a minute or so. I'll be right back. Alrighty. Should be good. Let me double check OBS. Cool, perfect. All right, so we do that. Unable to delete file. We'll go to main and we'll look for load game. So if we're in the load game match, we load, we set the state, and then we do save load system, delete save. Again, I think that's a little bit aggressive, unless you put protections in to save when the game crashes. But that's also risky. You want to like manage backups or something. This is a bit of a brutal, this is too roguelike for me. I know that some people are like, oh, but you could just like Alt F4 the game or something and abuse the saves. I don't care. Like, don't punish a player if the game crashes outside of their own will or outside of their own accord, right? Okay, so I think that's basically it. So there's some stuff about WebAssembly. Let's see where it goes. The example as is will, oh, right, because WebAssembly is going to be different with files and stuff, right? The example as is will compile and run on the WebAssembly WASM32 platform, but as soon as you try to save the game, it crashes. Unfortunately, well, fortunately, if you like your computer not being attacked by every website you go to, WASM is sandboxed and doesn't have the ability to save files locally. Supporting saving via local storage, a browser/JavaScript feature, is planned for a future version of our LTK. In the meantime, we'll add some wrappers to avoid the crash and simply not actually save the game on WASM32. Rust offers conditional compilation. If you're familiar with C, it's a lot like pound-to-find madness you find in big cross-platform libraries. In SaveLoadSystem.rs, we'll modify SaveGame to only compile on non-WebAssembly platforms. Okay. So I'll do that. It doesn't hurt anything on my end because I'm not running it on WebAssembly. So SaveGame, SaveLoadSystem. Where are we at? Here we are. So we'll modify save game. So it's not target arch equal WASM 32. And it says that pound tag is scary looking, but it makes sense if you unwrap it. Pound config means only compile if the current configuration matches the contents of the parentheses, not inverts the result of a check. So when we check that target arch equal WASM32, are we compiling for that? The result is inverted. The end result of this is that the function only compiles if you aren't building for WASM32. It's all well and good, but there are calls to that function, so compilation on WASM will fail. We add a stub function to take its place. So here we just, you might call it like a no-op, right? It literally does nothing. This is actually basically how the drop function is implemented, except it doesn't take a reference, it takes the actual data. But the drop function, well, the simplest drop function, an std memdrop, there are other ways you can drop things, and like certain things like file, when they drop, they actually close the file handle. So we're gonna do target arch equal WASM 32. Arch meaning architecture, right? Save game, and it's gonna take ECS and mute specs world, and then it literally does nothing. It's an empty function. And notice that it's grayed out because our IDE here with Rust Analyzer, everything, it's very kind and smart, and it actually tells us it's inactive because we're not on WebAssembly 32. That's not what we're targeting. So it's really nice that it tells us that, or that it shows by graying out. So we can't load if we have no save game, so we can cheat and not have to do the same for load game. So that's nice. So so this is the stub that we put out, and the pound config target arch WASM32 prefix means only compile this for WebAssembly. We've kept the function signature the same, but added an underscore before ECS, telling the compiler that we intend to not to use the variable. Then we keep the function empty. I didn't do that, so let me go add the underscore. And the result, you can compile for WebAssembly 32, and the save game function simply doesn't do anything at all. The rest of the structure remains, so the game correctly returns to the main menu, but with no resume function. So why does the check that the file exists work? Rust is smart enough to say no file system, so the file can't exist. Thanks, Rust. Wrap up. This has been a long chapter with quite heavy content. The great news is that now we have a framework for loading and saving the game whenever we want to. Adding components has gained some steps. We have to register them in main, tag them for serialize, deserialize, and remember to add them to our component type lists in SaveLoadSystem.rs. That could be easier, but it's a very solid foundation. There we have it. So let me check one thing. Yeah, something's broken. Something on my Stream Deck is broken. I'll fix it after stream. It's happened before. Alrighty, cool. That's it. That was a big beefy boy today. A lot of just kind of boilerplate back-end stuff. Enjoyable-ish. I really like the macro stuff coming in. And that reminds me, we need to check macro rules. So let's go ahead and open up a new tab. Rust macro rules. And I want to see that syntax because I think I understand it, but I want to take a look at that syntax. Patterns and designators. I talked about before, when you're building the pattern here, the first part here is the name, right? So we're naming something expression, and in this colon thing here is actually the designator of what the thing is, right? So what we're saying here is that expression, we could call it donkey. It could be $donkey. But then this colon expr here says, oh, it's an expression. If we said $donkey and then said STMT, it's a statement, right? So what we saw earlier was TY, which is type. So that matches what I was saying earlier. So that's important. We could do other things. We could do literals. We could do actual patterns as well. We could put patterns in this. Patterns in our pattern matching kind of. Identifier used for variable function names. All kinds of stuff we could do here that we can use when building out these macros. The one I care about is if we could see, is it repeat? Yep, here it is. Macros can use plus in the argument. Okay, so this is like regular expressions, right? They can use plus in the argument list to indicate that an argument may repeat at least once, or star to indicate that it may repeat 0 or more times. In the following example, surrounding the matcher with $, and okay, it's the exact syntax we saw. They used a star instead of a plus, but the exact syntax we saw. And we could see down here, we're saying it can have as many expressions as we want, and we're calling it Y. That's all we're doing here. So that's the syntax we saw earlier. $, and all this weird, like this weird comma plus at the end. Well, they use star. So yes, that does confirm my suspicion. Again, I had never done that on a macro I've written, so it's good that we actually check and make sure that we understand this. The tutorial did not really go into the macros at all. I tried to explain a little bit what's going on, but the reference here is a great place to start. But macros are still a bit obtuse, especially like your first time in. It's a little hard to see probably. Hopefully this helps though. There's the thing I was pointing out. This can take as many expressions as we want. We call them Y. Just trying to zoom in a little bit and reiterate. And then there's the overall syntax there. Again, plus it's like a regular expression, 1 or more, star, 0 or more. That's all. Straightforward, I think, if you understand regular expressions and all. Macros, again, are a little obtuse, I think, initially. What I found great, I mean, this is a pretty simple one, find min. We're literally just doing std compare min. That's pretty simple. You could do something like a ternary expression, like the ternary conditional, right? I mean, the way I did it, can I type in here? Yeah, the way I did it, I'm not going to build a macro, but basically do a macro that looks like a ternary and then thing, A, B. Like, I don't know what A and B is, but A is what you get if thing is true, and B is what you get if thing is false. Like, you can do something like that, right? It's a pretty easy, like, simple macro you can start with. And then you can have it like spit out a value, and then you can compare against the value, or you could use that value from the ternary. It's just an idea. Even though like Rust has perfectly fine ways of doing that inline, or not inlining, but compared to like C or something, in Rust it's nice because we could say let res equal if thing A else B. We could do this kind of thing in Rust, which is nice. But so that kind of gets rid of a lot of the usefulness of the ternary. But I think that ternary is a good macro to try building initially, something like that. I mentioned the other day I built a macro where it did a range over floating points by basically converting them. Based on the step, it converts into integers and then like casts those back down into the appropriate floats. It's a weird algorithm, but it basically makes discrete floats and builds an iterator out of those discrete floats. That's another kind of thing you could look into doing. And my syntax ended up being like a float range, and it was like 0 ... and I did support equal. I made it optional. But it could be like 0 ... 1.0, and then step, equal 0.1 or 0.01, whatever it is. You do a little bit of math and figure out, well, what do we do to convert that step to 1.0 or something, as an example, and you perform that same operation on both sides of the range, and then you do an iterator over that. So now you've kind of like normalized your floats in the range to be integers. And if that makes sense, you could do an iterator over that with the step of 1, and then like divide that by the initial operation to get back to floats. And it's again, it's weird, but it works. I suggest looking into it. It's a fun one to build. All right, that's enough of me going on about this right now. So let's, we've already wrapped up. So next time we're going to do Delving Deeper, which is a bit shorter, and then difficulty is even shorter. So I am going to do both of these next time, I'm pretty sure. And then we'll save equipment for its own session. So that'll get us through next week, Monday and Wednesday. Then after that, we'll be doing stretch goals and maybe 1 to 2 sessions. They're pretty short. And then it'll be on to generating maps, which is going to be all into algorithms and stuff. So Delving Deeper is going to be covering like dungeon levels and stuff, right? So I think difficulty is going to be changing monster difficulties, like making things harder. Especially as we go deeper into the dungeon. But what we're going to be doing here is generating multiple layers to the dungeon. So that's going to be a lot of fun. We have downstairs and going down a level and just like regenerating new maps as we continue to go deeper into the dungeon. So it can keep progressing as we run out of stuff to do on the floor, right? The game can keep going on. So that's it. I don't know if I was going to cover anything else. So I think that's good. So I want to thank anyone who showed up today. I really appreciate it. I'll do my usual outro here and say, if you're new and you want to see more, hit that follow button. I'd appreciate it. If you are watching this in the future on YouTube, congrats on being in the future. You can do all the fun YouTube stuff. I would appreciate that. You know, you could lick the like button. You could kick that subscribe button, notification bell. Leave a comment. Leave me some feedback. I do go off on tangents, which hopefully are useful, but leave me some feedback. Hopefully the tangents are useful. I know it's a little hard to critique code, which isn't actually my code, but if there's anything I could do to present it better, or if my tangents are not helpful, or if they are helpful, whatever, leave me feedback. I appreciate it. And that's about it. So until next time, I'll do the other thing. Hold on. I do these streams on Monday and Wednesday. I forgot to do the schedule. I do these streams on Monday and Wednesday. So we'll be back on, today is Wednesday, so I'll be back on Monday, whatever it is, the 24th or something, with the next one. And every other day besides Monday, Wednesday is gameplay stuff. So if you're interested in that, pop on in. I'm not going to go through the whole gameplay schedule right now. So until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
I was a North American fall webworm in my past life. Ah, those were the good old days. What were you in your former life?